My name is Anthony Senft, and this is Physics 2, Lab 1. So, a little bit of an overview here. We're going to go into the introduction of the charge tape experiment, then into the actual procedure and some of the observations and calculations I had with my experiment, and then a computational model that represents what we did. So, a little introduction here. The objective of this lab was to identify the excess charge on a piece of clear tape and observe its interactions with some other household items like a table or a pen. So in this lab, the students are going to be using pieces of tape, and other charged household items to observe like a transfer of electrons and these charge interactions. And as a result, I calculated that a single piece of clear tape has an excess charge of about 1.4 times 10 to the negative 8 coulombs. So some background principles that are really important to understand as part of this lab is going to be Coulomb's law, the idea of electric force and electric field, and of course gravitational force. All these things are going to have some interplay into how we calculated that result on the last slide. So now on to the experiment itself. Some assumptions that I made going into this was that air resistance is going to be negligible on the two tapes, that the tapes are point charges, and that all of these tapes, called U-tapes, have the same evenly distributed charge. So some of my observations that I made throughout this lab procedure was that tape 1, when interacting with my hand, was attracted to it. When interacting with another tape, it was repulsed by it, meaning that those are like charges, and we're trying to determine the charge on the tape. Then when we take a neutral table, tape 1 is attracted to it, so that doesn't tell us a whole lot, but it gives us a good idea of what's going on. And then finally, we take a negatively charged pen and our unknown charged tape, and we see that these two things are attracted. So we can conclude, since opposite charges attract, that the tape is a positive charge. And as noted, a lot of the other important observations made are noted in GlowScript code. So here are some of the calculations. First, we have the force of gravity, which, given some of the specifications of our tape from the procedure, I was able to calculate as 1.96 times 10 to the negative 3 newtons. The charge of the tape, which was kind of that overall result, is calculated with that equation derived from the electric field and Coulomb's law equation. And I got, as mentioned, 1.4 times 10 to the negative 8 coulombs. And then on the right-hand side of the screen, I calculated the number of electrons using that equation, the number of atoms, again, the equation given, and then I found the ratio of electrons per atom on the tape. So a little bit of a discussion here. What if the electrons were positively charged and the protons were negatively charged? Well, theoretically, this would have very little difference on the experiment except for the direction of these fields, which really just help us think about the situation more so than the actual physical properties. Same things would still be attracted to one another. And why is it important to handle these tapes as little as possible? Well, we want to avoid dissipating those charges as much as possible, because if we dissipate all of it, we're not getting an accurate answer. So now on to the computational model. Here's my code, so here's some of those observed values and constants that are important. I have K, which is just 9 times 10 to the 9th. Everybody has a good idea of that. Charge of a proton, and then gravity. My tape length was about 20 centimeters, so 0.2 meters. Tape mass is just the tape length times that value given in the procedure. And when those two tapes were floating above one another, it was about 3 centimeters separation between the two. So my distance is 0.03 meters. I then go into calculating my force of gravity and electric force, and then creating some objects similar to what we did in Lab 0, printing out some values just to make it easier to understand what's going on and see what's happening on the next slide. So here you can see that you have your different charges here. If you go back to the previous slide, you could see that the gravity arrow is in red and the electric arrow is in blue. So you have the electric repulsion from the orange piece of tape. That orange charge is pushing up on the green charge while gravity is trying to pull it back down. But since these forces are equal and opposite, it's not moving at all. And that's why we have that 3 centimeter gap in there. All right, well, thank you for watching. That's all I have.